Hello everyone and welcome back. So I've been building this pineapple model, procedural model in Houdini, and today I wanted to share how I did the crown in here, basically by doing manipulating attributes with Vex. So I thought it would be a good exercise to share here on the channel, and maybe you'll get a tip or two from it. So yeah, let's get into it. So let's start in a fresh new scene and drop a geo container, and we will start by creating a circle. So this is where we will instance the different leaves. Let's set it to XZ plane to be on the grid. And I'm gonna change the division just to 7, which is more or less the amount of leaves you have around. I'm also going to drop a polyframe to create the normals, because we will need them in a bit. So in this case, I want to set this to N. So they point, in this case, they point in. I would like them to point out. So I'm gonna drop a wrangle and just invert them. So V at N times equals -1. So now they point out. So that should be fine. And now we will instance these into a line. So let's create that line. In this case, I'm gonna use some values that work for me. So I'm gonna set these along Y and a length of about 0.11. So quite small, as you can see. 2 points, that's fine. Now I'm going to resample these to a defined amount. So resample, and I'm not sure if I'm creating curve view, I don't think so. Yeah, so I'm just gonna set maximum segments of 6. So we have 6 segments. Let me increase the point size. Is it in here? No, is in guides scale point marker size. Yeah, so we have 6 segments, as you can see. Now we can just try to copy these 2 points and see how that goes. So as you can see, that's fine. It's creating the different copies along the line, but I also want to adjust the p scale. So attribute adjust float, and in this case I'm gonna set the p scale to be changing along the bounding box, along the y. So I'm gonna set this to bounding box and set this to y, and as you can see, it will start small and then grow. In this case, I'm gonna set pretty small values, so we're around 0.04 on the minimum value and about 0.01 in the maximum value. So as you can see, it's creating this cascading effect. I believe I didn't change anything else in here. Then what we can do, we can create a class for each geometry. So let's do that with an attribute wrangle. And we will create I at class. It will be equal to the point number. So now we should have a class and we don't need to drop in a connectivity or something like that. Let me set this to flat display. So that's our first part done. Now let's see, what else do we have in here? We will need to rotate this to create the pattern of the leaves, which obeys to the golden ratio or golden angle. So we'll have to do that, but for now, let's just try to copy these 2 points. So if I create a line in here, and I make it along the z-axis and a length of 0.2 something. And now we copy these 2 points and we will start to create the different leaves that later will be leaves, I mean. So now we need to adjust a few things. Before we do the rotation, that will be a bit more convoluted. We can just work on the rotation because we need to move this up. So we have the normals, as you can see, that we created. We have the normals of the geometry. So from here, we can create an up vector. So attribute wrangle. And let's create an up vector. So in this case, with just by doing a cross product between the normals and the y-axis. So v at up, it will be equal to normalize, always normalize when you're doing cross products, and we will do cross between the normals and an up vector, let's say 0, 1, 0. And we should have an up. And let's look at that up. It will be like this. And now what we can do, in order to rotate these leaves up, we will do an attribute adjust vector. And in here, we will manipulate the normals. So in this case, we'll manipulate the normals. So let's set your normals. And we will just play with the direction and rotate. And we will rotate around the up. And if we rotate, now we can move this up, as you can see. And let's rotate it by 70 degrees, something like this. And now we need to play with the p-scale also. So let's do an attribute adjust float. And you can play with the p-scale, but I'm going to be a bit more precise in here. So I'm going to do again the same thing. So bounding box and along y. And in this case, I want to a min value of 0.2 or something and a max value of 1. So it increases along the y-axis. Starts small and then increases. That's the visual feedback I got from a reference. So that's something already, but we still need to work a bit more on this. So let's do that in the next part. So the idea now is to create some sort of bending on these, some bend effect on these curves. So they drop, like say with let's say with gravity, and we want to create that bendy effect. So for that, I'm going to use a rig wrangle, and we can do that. Let's start. Well, let's just drop the rig wrangle, but we will need a transform. So let's create an orient along curve. This won't work very well, but I'm going to show you how to solve that. So let's drop the orient along curve and export the transform attribute, and we can have a look at that transform if we scale it down. And it will look something like this, which if we do it one at a time, it would be easier to set up, but in this case, I want to do it all at once. So let's create a wrangle, the rig wrangle, and in this case, I'm just going to make sure I resample this and have a curve view. So I'm gonna resample these curves because right now they only have 2 points. So I'm gonna resample. Let me see what sorts of value did I use. So about 0.01, so quite a bit of resample, and I also want the curve view. So now we can deform them along the curve view. So let's look at the curve view. As you can see, it starts at 0 at the bottom and goes to 1. All right, let's manipulate that curve view attribute. So I'm going to create a variable called angle, and it will be a channel float that we can change. Then I'm going to create just an extra step to have the possibility to offset the curve view. So in this case, I'm going to grab the f at curve view, and I'm going to subtract a channel float called offset, and you will see in a bit how that works. And then I'm gonna make sure this doesn't go below 0 or above 1, so I'm gonna clamp this between 0 and 1. This trick I learned from Swalsh. And I'm gonna multiply the angle by the offset and another attribute that will work in a bit. And then we can just do pre-rotate for at local transform, and we will rotate by the angle and along, let's say, the x-axis. Let's see if that works for us. Oops, 100. So no errors, and now we can play with the angle. But as you can see, our transform is working in some cases, but not in the I mean, it's not working at all. This is all a mess because we need to calculate the proper transform attribute, because this one is not giving us a good result, as you can see. So let's calculate that transform, and for that we need to take a step back. So let's remove this orient along curve, and let's go back and calculate a proper transform. First of all, we need to, let's see this, let's disable these. And as you can see, they all go in the same position, and we need to offset them along the y-axis. So before we create the transform, we will do the rotation along the y-axis. So I'm trying to do this in a way that makes sense. I'm not doing this linearly. So I have some things that I have to go back and do one step at a time so you can follow along better. So I'm gonna start by creating a bounding box along y with the relative point bounding box that I'm gonna use later. So I'm gonna call it relative bounding box y, and it will be relative point bounding box, incoming geometry, v at p, and I just want the y-axis. This will just create a fall-off along the y that I'm gonna use in a bit. Then I'm gonna create in here a variable called golden angle. That will be the amount of rotation we will perform, and this will be a fixed value, so in radians. I'm gonna set it to 137.5. That's the golden angle. Then I'm gonna multiply that by the class, so along the different the different pieces. So I'm gonna get the angle, or not the angle, sorry, the golden angle, and multiply it by the class. So it rotates along the different pieces. Then we need to actually do the rotation. So let's do a vector for called quads, and it will be a quaternion, and we will rotate the golden angle, and we will rotate, of course, along the y-axis. So 0, 1, 0. That is fine. Now we just need to do the rotation. So v at p, it will be equal to q rotate, and we will rotate that quaternion, and we will change the position. So now we should have rotated, as you can see, and if we look at the result, we will have something like this, which in this case, let me see. Yeah, this just if I disable these in here, as you can see, this just rotates along the y-axis. I believe this is correct. Yeah, I guess so. So let's just continue and we will see how that goes. Let me just check in here. So, oh, there's something wrong in here because we are rotating, but if you see the normals, they are a bit hard to see. So let me go to guides and scale normal. As you can see, the normals don't get rotated and they get all messed up. So we also need to rotate the normals. So let's go with v at n, and we can rotate the n. And now we should have the correct normals. And as you can see, now it's all organized. And you see by the alternating pattern in here along the y. That's why we did that rotation with a golden angle, whatever that means. Anyways, that's our rotation done. Now that we have the normals properly oriented with that rotation, we want to create the transform attribute. So for the transform attribute, that shouldn't be too difficult. We will create in here, so we will set the vector n. It will be, let's just normalize it, normalized v at n. Let me increase that for you. Then we will take advantage of the look at function that just creates the different cross products by default. We don't need to worry about that. So we will do, and this takes as an argument from, to, and up. So from, to, and up, and we need to define those. So the n will be our 2 axis, our 2 component, and in this case we want to invert it, and the vector from can just be 0, 0, 0, and the up just along y, so vector up set 0, 1, 0. And now we have the look at. Let's just save that as an X form. So X form, oops, X form, a 3x3 matrix. And let's also save, I might need this, so I'm gonna save these normals as an alternative attribute. And of course it's erroring out because I don't have so equals in here. So let's look at that transform and see what it did. So let's actually remove these normals in here and look at the X form. Make sure we set these as a marker and as an axis and reduce. So as you can see, we have the z-axis pointing out. We have the up axis. The up is the green, and we have the cross product of that along the x-axis, let's say. So that should give us a nice transform for our orientation. So we copy these 2 points, and now we enable this attribute wrangle, but it won't recognize that attribute that we created. So, and the reason I didn't call it transform is because it will affect our copy 2 points and not pay attention to p-scale or normal or anything. It will just prioritize the transform attribute. So we will do instead attribute swap, and we will do a move from the X form, and we will name it transform. And now, as you can see, our transform is working perfectly, and we can come in here and play with the bending, and we can bend it as much as we want, and we can also play with the offset and bend just the tips. In this case, I didn't use offset, and what sorts of values did I use in here? So let me see, 0.15, so 0.15 will be the correct approach. Now, we can do a simple sweep and create the geometry. So let's create a ribbon and reduce the size. We can reverse this, and let's enable the lighting and remove this. And we can just apply a scale and change this to, where is the preset? So fill, and change it to B-spline. We can possibly increase this and change the bottom, and we start to get the desired results. But I still want to manipulate this a bit. I want to create some dents in these lips. That's typical to pineapple crowns. And that will be an extra step. If you want to keep watching, let's meet in the next part. So there are still a few things I want to change about this rotation, because in my reference they don't rotate so much at the top. They are a bit more straight. So that should be easy. You can create attribute adjust float, and I'm gonna call it relative bounding box, and I'm gonna change this to bounding box and along Y default settings. And now I can just come in here and multiply this by that attribute. And now it won't. Did I invert this? So 0 and 1, yeah. And we can come in here and invert this, something like this. So they will rotate more in the bottom and less at the top. Or we can just invert it in here, it's the same. So now we want to create some dents on the sides of the leaves, on the edges. And for that, we will need to do the meshing in a different way. So this is what I came up with. It's a bit over the top, it's a bit complicated, but it should allow us to do this directly without having to point the form or without having to do some rigging, some deformation with the bone deform that we can also do. I tried different approaches, and this one was working the best for me. So instead of outputting geometry, I'm gonna change this to columns and change this to 1 only, and this will create the geometry. And now we just displace these curves along the normals with the sine function. So let's see. Of course, we don't have any normals, so these won't be properly oriented. So let's go one step at a time. So I'm gonna create the sweep, and I'm gonna set this to 0.063. That's the value I used. And we can also change the p-scale along the y, but I'm not going to worry about that now. So having these curves, we can do a resample, and we will resample quite a bit to have enough geometry. So 0.0005, so quite a bit, as you can see. You can change how much you want. And I'm gonna set these to subdivision curves. That's an important step. Otherwise, we will get faceting on our curves. I'm gonna also output the curve view. And the first thing I'm going to do is to create an orient along curve. And I'm going to set the tangent to n. So let's see how that works. Oops. Let's disable the resample and scale the normal quite a bit down. So this is just the tangent along the curve. As you can see, it's following the curve. That will be important for us. And what's the next step in here? So we can now, let's do the displacement and see our issue. So attribute wrangle, and we can do v at p plus equals v at n, also along the normals, and we will do the scene of the curve view multiplied by the repetitions, and we can also multiply it by pi to have a perfect offset, and then we can just multiply everything. So multiply everything by an amount of displacement. So let's call it this. So this won't work very well. Let's change the repetitions to 65 and let's create the displacement. As you can see, the normals are not great. Let's remove these normals and just move the position. So as you can see, we need a proper normal for this to work because right now we don't have that. So let's undo and do the normal. And let's see how we will do this. So first of all, we need to calculate the proper normal. And we need to go a step back and create the orientation when we do these copy to points. So right in here, after we change the normals, we will need to create an attribute. So attribute wrangle, and we will create the double cross product. So if you remember, we saved out an attribute called _n. And if we have a look at that, so marker vector, that's a copy of our normals. And we can take that attribute and do a cross product with the normals. So vector side, it will be equals to normalize, and we will cross between the normals, and that's an attribute. And now if we do if we saved out this attribute v at out, it will be equal to normalize and another cross between the side and again the normal attribute. Let's see what that gives us. So why am I writing this? So okay, and of course this will error out because so normalize cross and normalize cross between the side and the end. So this is correct. Oh, I need an equal sign in here. So let's look at that attribute. So let's enable this and create a marker and vector. And this will be the orientation that we need, because right here we are changing the normals, the rotation of the normals, and we need that orientation to feed into our, as you can see, this is the attribute we need to feed into our curves. Not only that, we also need an extra step in here. So we already have this out attribute that we will take advantage. And after the rig wrangle, we also need that rotation that we got from the rig wrangle. So as you can see, if I rotate this now, it won't follow. And I try to rotate it in here, but this is doing something in the background with the transform attribute that I'm not sure how to mimic, how to do the rotation right in here. So we will do it in a slightly different way. So after the algebraic attribute wrangle, we will create the proper axis that we will need later. So let's create a wrangle, another wrangle, and you're probably tired of this. So let's call it vector local x, and it will be a normalize between the out and the up vector, I believe. So set 0, 1, 0. Let's see how that looks. So v at local x, it will be equal to local x. Local x. Today I can type, so what's the problem in here? Local underscore x. What's the problem in here? So normalize. Oh, sorry, we need to cross in here. Sorry about that. So cross. That should work. Let's see how that looks. So if we look at that local x and marker and vector, and as you can see, we now have the proper orientation with the rotation and everything. We now have the proper orientation to do the displacement. As you can see, is following the shape of the curve. And if we do the sweep, now we just need to invert the first primitive or invert the second. So for that, we will have to do again something. So let's see our displacement. And let's reduce this. And it's still displacing along the normals that we haven't defined yet. So let's do another angle in here, yet another angle. And we will do v at n will be equal to v at local x. And now it's displacing, but we have the same direction in both sides, so we need to invert this somehow. Let's enable this. Let's reduce the displacement to 0, 0, 1. Let me pick in here. As you can see, it's inverted in this side. So what we can do is simply do a sign. So float sign, it will be equal to I at prim num modulus 2. And we need a value between -1 and 1. So let's multiply this by 2.0 and subtract 1. And now we can just multiply this by the sign, or inverted sign. And now, as you can see, it's working perfectly. So, but this is creating some sort of, well, the sine wave, which is rounded. So what we can do is to do, I believe it's called a sine, which is, how is called? Let me see in here. A sine, not sine, sorry, which is the arc sine. And we do this in here, I believe. And now we will have the flat look, or this serrated look. And a lot of work just to create this, but as you can see, we now have a proper orientation and everything should work fine. So let's create the geometry now, and for that I'm just going to use a very cheap method of using the skin stop, and this will connect everything. If we do group of n prims, it will connect just two, and we do normals. And let's see, they are inverted, so we can reverse them in here. And yeah, everything should be working, as you can see. And we can probably play with the displacement, so a bit less. And now we can do a UV flatten and disable manual layout, and they will be properly oriented. And you can also decrease the p-scale along y, but you know how to do that already. We've done most of that. We've done plenty of that in this lesson, so just with the bounding box y. And yeah, guys, as you can see, this is not as straightforward as I would like it to be. And I tend to overcomplicate things and try to create nice setups to share with you guys. And hopefully you got some tips out of this. If you didn't understand everything, go ahead and leave a comment, and I might try to explain it better. And as always, you can grab the file on my Patreon alongside with exclusive tutorials, and I also have some courses in there that you can check out. And please let me know in the comments if this was useful in any ways. We did quite a few things, and we tried to do this in a clean way, but I understand that with so many wrangles, sometimes it is hard to follow. But we didn't do very complicated stuff. Most of it was quite simple. Maybe the most complicated part was this lookat function, or the rest is just cross products and manipulating attributes. Hopefully this was well helpful, and I'll see you next time. Thank you.